lower the freezing point of the water in order to make a reaction?
Yeah. Yeah, so what you're going to do is, in this experiment, okay, so you're going to put your ice cream mixture in a plastic bag. Okay, so here's your ice cream mixture. And then you're going to immerse this in ice. Now, if it's just pure ice, that has a temperature of 0 degrees. If this is a water solution, it has a freezing point lower than 0 degrees, so you need to put some rock salt in there too. So you need to figure out how much salt to add to the ice to lower the freezing point to be able to freeze your ice cream mixture. Okay, so let's do this calculation. Calculate the freezing point of a salt water solution when 50 grams of salt is dissolved in 1 cup or 240 milliliters of water. Now note that this calculation is actually very similar to the one we just did. Okay, so for the one calculation we just did, okay, so for boiling point elevation, the equation of delta TB is equal to I times KB times M. So for freezing point depression, the equation is delta TF equals I times KF times M. So delta TF, this is the freezing point depression. I is the same as it was in this equation. KF is the freezing point depression constant, which is different than the boiling point elevation constant. And then M is the molality, just like it was in the previous equation. So to calculate the freezing point of this salt water solution, the only thing we need to change is KF. Okay, so in table 13.2 KF water, is 1.86 degrees per mole ounce. So what this tells us is that if you have a 1 mole ounce solution of a solute water, that's going to be pressed to freezing point of 1.86 degrees. Okay, so let's plug in our numbers just like we did before. Okay, so delta TF is equal to, what was I for that salt water solution? 2. And delta for KF is 1.86. Then the molality of that solution from the equation is 3.56. So if we do this calculation, this gives us our new freezing point.
And 13.2.
So 13.2.
Where did the 3.56 come from again?
Yeah, this is actually this previous calculation. We have 50 grams of salt divided by the molar mass gives us the moles of salt, divided by the kilograms of the water, 0.24, that gives us 3.56. So what was this again? 13.2? 13.2. So that means that the freezing point of the salt water solution is going to be minus. So the freezing point of the NaCl in water is minus 13.2 degrees Celsius. Pardon?
Because you're using
CaCl2?
freezing point of CaCl2.
No, that's for NaCl.
Okay.
Yeah, because you're looking at the next question, George. CaCl2 is next one.
Would the water be completely saturated with the NaCl, or could you add more to reduce the?
Oh, you can add more because, yeah, that's actually another thing you do. Because you want to look, remember that table we looked at last week? It was the effective temperature on solubility. That's figure 13.3 on page 444. And according to that table, you can dissolve about 40 grams of salt in 100 grams of water. Okay, so if you have 50 grams and 240 milliliters, that's not going to be saturated.
So you could actually double the.
Now, when we do this lab, we actually limit the amount of ice that you can use because, well, we don't have infinite supplies. Okay, so we don't want you to, and then we have also the salt too. We have a lot of salt, but we don't want you to use like a huge amount of salt. For which one? Oh, so that's page 4, figure 13.3 on page 444. Now the other thing you want to do when you make ice cream is you need to estimate the concentration of salt used in the ice cream that you make in order to estimate the freezing point of your ice cream mixture. Okay, because note that when you make your... Okay, so let's just say that you estimated the freezing point of your ice cream mixture to be, say, minus 10 degrees. When you make your salt ice mixture, are you going to calculate the amount of salt to add to the ice so that the temperature is going to be minus 10 degrees? Or will you calculate the amount of salt used in your ice cream mixture so that this mixture is going to be lower than minus 10 degrees? Okay, so again, let's just assume that this has a freezing point of minus 10 degrees. Do we want this salt ice mixture to have the same freezing point or a lower freezing point than minus 10 degrees?
Almost the same.
Okay, now remember from, we're going to review this in a few weeks. In Chem1A we talked about heat, so note that what you want to do is we want to remove heat from this ice cream mixture into the salt ice mixture. Okay, so we're trying to remove heat. If this mixture was originally at, say, room temperature 25 degrees, and we put it in a salt ice mixture of minus 10 degrees, what's going to happen to the temperature of this ice salt mixture? It's going to increase. Okay, so if you want this to be minus 10 degrees, this salt ice mixture has to be lower than minus 10 degrees.
That could actually, the change in temperature,
yeah, you can calculate using that. Yeah, so another way, rather than using this ice salt mixture, see another way which you may have seen in magazines or online is instead of using that, you could use liquid nitrogen.
Do we have that? Can I bring it?
Does anyone know what the boiling point of liquid nitrogen is?
Room temperature.
Negative 200 degrees Celsius.
It's yeah, the boiling point of liquid nitrogen is 77 Kelvin. Or let's see, that's same as minus 190. What is that? Minus 196 degrees Celsius. So that's pretty cold. Now you want to be careful if you've ever used this. You got to be careful using it because, see, you put it in a thermos, which is an insulated container, but when you put it in a room temperature thermos, it starts boiling because the temperature of the thermos got to get cold too. And usually when it starts boiling, it starts spattering out of the thermos. And then if you have this really cold liquid nitrogen spattering on your fingers, feels like it's burning your skin. Yeah, so because when I was in graduate school, we were using liquid nitrogen to cool these traps. So, we have this big container of liquid nitrogen we can dispense into the thermos. And then, like I said, it would spatter all over the place. So, and then, because I got some, it's actually so, like I said, it feels so cold, it's actually feeling like it's burning your skin. So, really be very careful using this. And then another way to do this too, if you want another kind of bath, there's like you can use like a dry ice acetone bath. Dry ice is another name for CO2 solid. And acetone is a common organic solvent. Anyway, this has a temperature. This bath has a temperature around let's see, minus 70. Let's see, I think it's like minus 78 degrees Celsius. So this is another bath you can use if you want something colder than ice. And then you can buy. I know that when Save Mart was still the Lucky Store down in South Main, you could buy like 5-pound blocks of dry ice for a few dollars. I'm not sure if they still sell dry ice now. And acetone you can buy this in the drugstore as fingernail polish. And you have your minus 78 degree bath, which is that's really cool. So you may have seen these on videos. Like someone puts a banana in a liquid nitrogen bath, and they can use the banana as a hammer. You guys seen that before? I tried that when I was in graduate school, and it didn't really work. But the banana got really mushy. So it got cold, and actually I had it in it for quite a while, and it just got mushy. It didn't really get. So I think you better have it in it for quite a while, not 5 or 10 or 20 minutes. Probably have it in for like an hour.
You do that.
Yeah. Okay. Okay, so this has to do with your car.